Okay, we are going to continue the last method for solving the second order non-homogeneous equations. Okay, with the linear, second order linear because and constant coefficients non-homogeneous equations. And then we have learned how to solve it using undetermined of coefficients. Now if the fx is in the form of tangent x, cotangent x, secant, cos x, or 1 over x power n, then the undetermined of coefficients cannot be used because undetermined of coefficient, the fx is either polynomial, exponential function, sin or cos. If we got tangent, cotangent, secant, or cos x, then we cannot use undetermined of coefficients. So in this case, we are going to use variation of parameter. So to use variation of parameter, the general solution is very easy. It's only y, because you want to solve this second order non-homogeneous equation. Is actually you want to find or solve for the y. Y is given by u y1 plus v y2. And to solve the non-homogeneous equation, as usual, you have to solve the homogeneous equation first. To solve homogeneous equation, you let the fx initially you let it equal to 0, and then you will replace the second derivative by m squared. Oh, sorry, this should be, this one is the first derivative. And then replace your first derivative by m, y by m power 0. Later I can share to you for your your attendance. Some of you took the attendance and then just left. We will show you the records who are active or who are just open and not around. Can you all hear or not? What I'm talking?
Can Doctor?
Yes, madam.
Yes, Doctor.
Yes.
Yeah, so I will proceed. To solve the second order non-homogeneous, as usual.
Doctor.
Yes. And then let's solve the homogeneous equation first. Let's the right hand side equal to 0, and then the second derivative by m squared, first derivative by m. Y is m power 0 or 1. Then you get this is so-called characteristic equation. And then solving the characteristic equation, which is a quadratic equation, you have three cases of your homogeneous solution, or the YC. You've got three cases, where the first case we have real and distinct roots, means we have m1, m2 are real number and are different value. Let's say m1 and m2. Then the YC is actually the homogeneous solution. Will be A E m1x plus B E m2x. So the y1 is actually you just eliminate the constant A and B. So the first one here, this is the y1, this will be the y2. If second case, your characteristic equation got real and same roots. So we have A E mx plus B x E mx because clash. If you just put A E mx plus B E mx clashing, that's why you have to multiply by x, as what you learned in undetermined of coefficients methods. Hence, for real and same roots, your y1 is E mx, y2 is x E mx. The third case, you may have the imaginary roots where the m is alpha plus minus beta I. Then the yc is E alpha x bracket A cos beta x plus B sin beta x. So your y1 will be, just eliminate the A. Then E alpha x cos beta x will be your y1. And then the y2 will be E alpha x sin beta x. So this is the y2. In first step, you find the your homogeneous solution, obtains a YC. Later on, extract out from YC, extract out your Y1 and Y2 by eliminating the constant A and B. Okay, second step, you evaluate the Wronskian, labeled as W. Is actually determinant of, first row is Y1, Y2. Second row, you differentiate your first row, differentiate Y1, so it's Y1 prime. Differentiate your Y2 is a Y2 prime. And this is determinant. Determinants, you evaluate determinant using main, product of the main diagonal, which is Y1 multiply Y prime 2. Minus the product of the other diagonal, which is Y2 multiply Y1 prime. Okay, after that, the U is actually given by the formula is negative integral of Y2 fx, over AW dx, and then plus with equal, integral constant A. V is, integral of Y1 fx divided by AW dx plus B. A is coefficients of the your second order or second derivative. You have here. This is A. You got A y double prime plus B y prime plus C y equal to fx. The general solution is given by y equal to U y1 plus B y2. Okay, after that, after it obtains a U and V, put it into your general solutions. The formula is U y1 plus V y2. So, any question? I didn't. I think in the author, the PDF there, we got the derivation of the formula UV, but here I just straight to the formula. So, any question? Can I proceed to the example?
Yes. Proceed, doctor.
Yes, doctor.
Okay. So, first, example 1, solve for y double prime plus 36y equal to cosec 3x. So, the right hand side here, is not sin or cos, not polynomial, not exponential functions. Then you can only solve it using variation of parameter. So first step, we get the characteristic equation. So to get characteristic equation, first of all, you will find the homogeneous equation. In the homogeneous equation, you let the right hand side equal to 0. So this is a homogeneous, second order homogeneous equation. Second order homogeneous equation is to let the right hand side equal to 0, and then the characteristic equation can be obtained if you replace the second derivative by your m squared. So 4m squared. Okay, y replaced by what? Y. M or 1.
One.
Yeah, be careful. Some of you will tend to replace this by m. So y is replaced by 1. And then you simplify, so m squared plus, divide by 4, plus 9 equal to 0. You have a m is m squared equal to negative 9. So your m, you have actually square root negative 9, which is square root negative 1 times square root 9. Square root 9 you get positive negative 3. Square root negative 1, which is your I. So m you get positive negative 3i. Positive negative 3i. So what is a YC? Where's a YC? Okay, where's the YC? This is a third case, complex root. So what is the YC? If you cannot remember, look back, look back the formula, imaginary roots. Do you have alpha?
No.
Okay,
No.
no means alpha is 0.
0.
So you got, so E0x equal to 1. Okay, beta is what? 3, right? Okay, it will 3.
Yes.
So you will get A cos 3x plus B sin 3x.
3x.
Yeah, this is how you read the table for the homogeneous equations. So in this case, you will get the YC is A cos 3x plus B sin 3x. So after you get YC, extract your Y1. So Y1, just eliminate the A. So this will be your Y1. So Y1 will be cos 3x. Then Y2 is sin 3x. And then Y1 prime is differentiates ddx cos 3x. So you got negative 3 sin 3x. Y2 prime is ddx your sin 3x. You get positive 3 cos 3x. Okay, and then you find the Wronskian label as W, which is first row. Just put up from here. Just put up into the determinant form. Cos 3x, so this is sin 3x, so negative 3 sin 3x, and then this is 3 cos 3x. Okay, evaluates your determinant. Determinant. So you have cos 3x multiply 3 cos 3x, so it's actually 3 cos squared 3x. So minus, this is minus, minus and negative, so become positive 3 sin 3x times sin 3x, so sin squared 3x. So you factor out 3, you have the cos squared 3x plus sin squared 3x, which is equal to 1. So the Wronskian, you get the answer is 3. So this second step, find the Wronskian. Third step, find the U given by the formula negative integral of y2 fx divided by a and w. Okay, y2 is here, sin 3x. So we put out your y2. Y2 is sin 3x. Okay, fx, to get fx, look back the question. Okay, fx is here, cos x 3x. Cos x 3x. A is here, coefficient of the second derivative, which is 4. So you got 4 here. Okay, W you obtain in step 2, which is 3. Then integrate respect to x. So you have the constant here. Okay, 4 times 3, 12. So mean you can factor out the constant, negative 1 over 12. And then cos x is actually, cos x is what? 1 over sin or 1 over cos? Okay, where's the cos x? Okay, do you still remember what is cos x? Cos x is actually 1 over sin. So mean you have sin 3x, cos x 3x is actually 1 over sin 3x. So sin 3x and cosec 3x can be cancelled. So you have only negative 1 over 12 dx. So integrate 1 respect to x, you will get x, and then plus with a constant a here. So basically, variation of parameter is not that tedious, but you may face with difficult integral. It's not that tedious compared to the undetermined of coefficients. Just maybe you have difficulty to do integration. So you get the u already, which is negative x over 12 plus a. Then you find the v, which is integral of y1 fx over a w dx. Okay, y1 in step 2, y1 is here, cos 3x. Okay, then you put your y1 cos 3x. Okay, fx is the cosec, cosec, okay? Cosec 3x, a is 4, w is 3. So again, you can factor out the constant 1 over 12, okay? 1 over 12 here. And then, cos 3x, cosec is 1 over sin. So it's sin 3x dx. So how do we integrate cos 3x over sin 3x? What is the answer? How do we integrate this one? Okay, you may use
substitute.
Yeah, substitution. You use u equal to sin. Then you let your u equal to sin 3x. Then you du differentiate sin 3x. You got 3 cos 3x dx. Okay, and you notice that in your numerator you got cos 3x, right? You have cos 3x dx. Then cos 3x dx replaced by du over 3. So your integral of cos 3x dx over sin 3x will be sin 3x replaced by u, cos 3x dx replaced by du, 1/3 du. So now you can easily integrate du over u, which is ln u. Replace back the u is actually your sin 3x. So that's why you got 1 over 12. And then from here you have 1/3. Okay, ln u is actually sin 3x. So plus b. So you obtain your u and v already. Okay, after that the general solution will be u y1 plus v y2. So put back the u. Okay, u that we obtain is negative x over 12 plus a. In the u you have negative x over 12 plus a times the y1. Okay, y1, look back in your step 2. y1 is cos 3x. Okay, we got here cos 3x. Okay, plus back the v that you obtain in step, this step. Okay, your v is, total here is 1 over 36, ln sin 3x. So you have 1 over the 36 ln sin 3x plus b. Okay, v2 is sin 3x. Okay, and then you may expand to arrange in the ways that you have, like the solution for your undetermined of coefficient. So a cos 3x. You got a cos 3x. So here b times sin 3x. Okay, this part is actually your yc. Okay, and the bottom part that without a and b is like your like the yp in your undetermined of coefficient. mean negative x over 12 times cos 3x. Negative x over 12 cos 3x, and then this one plus 1 over 36 ln sin 3x times sin 3x. So this is a solution by variation of parameter. So this part is look like the yp in the undetermined of coefficient. But this example you couldn't solve it using undetermined of coefficients. So I will repeat it one more time. Maybe first time you a bit look like confusing. Okay, you have this case, second order non-homogeneous equation, but in this case the right hand side here is not polynomial function, is not exponential function, is not sin or cos. So you cannot solve it using undetermined of coefficient. You can only solve it using variation of parameter. Then first step, you must get the yc as what you solve it in undetermined of coefficient. Mean yc is actually solution for your homogeneous equation. So for your homogeneous equation, in this case you get exactly complex root. So whereas the alpha is 0, you have your beta is 3. So yc is a cos 3x plus b sin 3x. And then from yc, eliminating your a and b, break it, the first solution will be your y1, the second is your y2. And then you differentiate your y1 and y2 to get the Wronskian. Wronskian is actually determinant of you have y1, y2. Second row is actually you differentiate the first row, calculate like you calculate the determinant of a matrix 2 by 2. After that you just plug in into the formula to find the u, which is negative integral of y2 fx over a w. A is coefficient of the second derivative. Y2 is here. Fx is the right hand side of the second order non-homogeneous equation. This is the fx. And a is a coefficient of the second derivative. This one is the a. A is 4. So you plug in the a and w. Then after you your integration of u, put it integral constant plus a. V is positive integral of y1 fx over aw. At the end of your v, you need to put in plus b. So lastly, the general solution will be uy1 plus vy2. So when you collect the term with the constant a and b, that is actually your yc. The term without a and b is actually look like the yp in your undetermined of coefficients methods. Do you have any question before I proceed to maybe the second example?
Doktor,
Yes.
yang W tu kan,
Yes.
macam mana boleh dapat 3?
You simplify and using identity matrix.
Oh.
Cos 3x multiply 3 cos 3x, 3 cos squared 3x. And then this one is minus. Minus, and then you have negative. So minus with negative positive. 3 sin x times sin x, so 3 sin squared 3x. Factor out 3. Cos squared 3x plus sin squared 3x. This one is 1. So 3 times 1 you get 3.
Oh.
This is identity of trigo, not matrix. Identity of the trigo.
Okay.
So any more question? Okay, if no, I will proceed to the second example. Solve y double prime plus y equal to tangent x. So first step, when you see non-homogeneous equation, okay, you will have to solve the homogeneous equation first. Solve your second order, okay, homogeneous equation. Means let right hand side become 0. Okay, after that, get the characteristic equation by letting second derivative by m squared. So y is 1. So this will be similar, okay, to the example 1. So your m squared you have -1. So mean m is plus minus I. So again, you have a complex root, okay, whereas the alpha is 0, beta is 1. Hence the yc you will have a cos 1x plus b sin 1x. So okay, from yc, eliminate your a, that will be your y1. So your y1 is cos 3x. And then the y2 will be sin, cos 1x only. So in this case, y1 is only cos x. Differentiate y1 is negative sin x. y2 is sin x. Differentiate your y2, you get, okay, positive cos x. And then, okay, this is second step, finds the Wronskian. So, okay, all the formula will be given. Wronskian, the formula for u and v will be given. Okay, I think now you have the online or take-home test. No formula given also. I think you will open the books, right? So the Wronskian, you have, okay, determinant of y1. This is cos x. This one is negative sin x. Second column, first row is y2 sin x. Differentiate y2. This is cos x. So again, similarly, cos x multiply cos x. You have cos squared x. You have actually negative, and then, okay, negative minus. Remember how you calculate determinant? This one, you got main product, main diagonal, product of main diagonal, deduct the product of the other diagonal. So minus, okay, sin, this is okay, negative sin squared x. So negative, negative, positive. So again, this one you get 1. For this example, the Wronskian is 1. Okay, W is 1. So A is 1 here. A equal to 1. Okay, this is W. So plug in the A, W, the A, Fx, W into the formula for your U. So U is negative integral y2. Y2 is sin x. So you have sin x. Fx is tangent x. Tangent x. A is 1. W is 1 dx. So integrate sin x, tangent x. So tangent x you can change to sin over cos. Right, put it here. Equal to negative. Tangent you change to sin x over cos x dx. So now you got negative sin squared x over cos x. Okay, you have to use against put here. You have the identity trigo cos squared x plus sin squared x equal to 1. So we want sin squared x will be 1 minus cos squared x. So that's why you have here sin squared x will be 1 minus cos squared x divided by cos x dx. So basically, Okay, variation of parameter is a problem how you integrate, because all the formula is given. Okay, you may just face the difficulty to integrate. So the u, and then to integrate this one, you can break it become 1 over cos. You can break because the denominator is only one term. If your denominator 2 term, you cannot break like this. So 1 over cos x minus, okay, you have cos squared x divided by cos x dx. So integrate, okay, 1 over cos, okay, let's create 1 over cos. 1 over cos is secant x. So this one, you simplify cos squared x divided by cos x, just left cos x, okay, dx. Okay, and then I will expand in the negative, so become negative, negative, this is positive. So integrate positive cos x minus secant x dx. So integrate cos, I think you have no problem. Integrate cos, you get positive sin x. Then you may have, okay, difficulty how to integrate secant. Okay, the result for integration of secant is actually you got ln secant x plus tangent x plus c. Okay, and you may, okay, this one, okay, how to integrate secant x, you may have, okay, learn it in calculus. Okay, in case you forgot, okay, I will just, okay, show back how the integral of secant x, you get ln secant x plus tangent x. If I multiply secant, okay, if I want to integrate secant x dx, I multiply by secant x plus tangent x, and then I divide back by secant x plus tangent x. So this one is actually you multiply by 1, so it won't affect, okay, back your integral of secant x dx. And then this one you will get, you expand in your numerator, you will get secant squared x plus secant x tangent x divided by secant x plus tangent x dx. Then if you use case substitution techniques, if you let your denominator is u, if you let u is secant x plus tangent x. Okay, your du, differentiate secant is actually you have secant x tangent x. Okay, differentiate tangent, you got, okay, secant squared x, okay, dx. So you notice, okay, this one from here, you will change to the integral of du over u. If your denominator is u, differentiate secant, you got secant x tangent x. Differentiate tangent, you got secant squared x. So your numerator will become du. So integral du over u, you get ln u. Okay, where the u is actually your secant x plus tangent x. That's why you got ln secant x plus tangent x. That's why you integrate secant x, you should have ln secant x plus tangent x. Suppose you should have learned this one during calculus class. So this is the u. So now we are going to find your v, which is integral of y1 fx over aw. Okay, so look back, what is the y1? y1 is here. y1 is cos x. your y1 is cos x, fx is tangent x, okay, a is 1, w is 1. A is 1, w is 1. So against tangent x, you change it to sin over cos. So tangent become sin x over cos x. Okay, and then you can cancel out the cos x. So this round you just have the simple integration. So you have integrate sin x dx, where you get integrate sin is negative cos x, so it plus b. So you already obtained u and v, hence your general solution will be your u. Okay, put back what's the u? U is here. U is sin x minus ln secant x plus tangent x plus, here put a. We put a, for the v we put the b. So the u is sin x minus ln secant x plus tangent x plus a multiply y1. Okay, y1 is cos x. Okay, plus the v is here, negative cos x plus b, y2 is sin x. Then if you expand, we expand the term with the a and b first. So you get back a cos x plus b sin x. So this is a part yc. And then you expand the term without the a and b. You don't expand the term without a and b. So mean you got here. Then don't forget this one also, this one also. So you have sin x cos x. Okay, minus ln secant x plus tangent x multiply cos x, and then minus cos x sin x, minus cos x sin x. So these two terms cancel. So your yp is only this term. So means the general solution, you have a cos x plus b sin x, because these two terms cancel each other. Okay, it just left. This is minus ln secant x plus tangent x multiply cos x. So this is the general solution for the second example. Okay. Do you have any question before I proceed to the one more example, and then we'll give you one exercise for you to do for the bidirectional parameter? Any question, okay? Before I proceed to the third example.
No.
Okay, if no, we are going to move to the third example. Okay, the third example, solve y double prime minus 4y prime plus 4y equal to x plus 1 bracket x plus 1 multiply exponent 2x. So similarly, first of all, get the second order homogeneous equations by letting the right hand side equal to 0. So you got y double prime minus 4y prime plus 4y equal to 0. Later on, get the characteristic equation by letting second derivative by m squared. y prime by m. So y is m power 0 or 1. Okay, and then find the root of your characteristic equation. So this will be m minus 2. Mean you have m1 equal to m2 equal to 2. We have the repeated, this is the same roots. So means the yc is actually a exponent 2x, and then because you have the same root, b, you must multiply by x, exponent 2x. If not, a and b term are clashing. So that's why for same root, a e 2x plus b here, you have to multiply by x. Then identify the y1 by eliminating your a, your y1 will be exponent 2x, y2 is x, exponent 2x. So differentiate y1, we have 2 exponent 2x. Okay, to differentiate y2, this is in the form of uv, where the u is actually your x, v is actually exponent 2x. So your u prime will be 1, v prime will be 2 exponent 2x. That's why your y2 prime will be u v prime plus v u prime, which is 2x exponent 2x plus exponent 2x. We have u times v prime. So 2x exponent 2x, and then plus v u prime plus exponent 2x. So this, after step 1, find the Wronskian, which is determinant of y1. y1 here you got exponent 2x. Okay, the second row, first column is y1 prime, which is 2 exponent 2x. y2 is x exponent 2x. This is y2 prime, which is 2x exponent 2x plus exponent 2x. So calculate the Wronskian. You have exponent 2x. This one first. Multiply 2x exponent 2x plus exponent 2x. Okay, minus product of the other diagonal. Minus 2, okay, 2 here, x exponent 2x times exponent 2x. This one times this one. 2x exponent 2x times exponent 2x. Then you may expand and simplify. So you expand in, so you will have 2x, exponent 2x times exponent 2x will be exponent 4x. So plus exponent 4x. So the second term is minus 2x exponent 4x, because exponent 2x times exponent 2x, you just add up the power. So you simplify here, 2x exponent 4x minus 2x exponent 4x. So in this case, your Wronskian is exponent 4x. Then you calculate the u. Okay, u. Too fast. Okay, u, you have negative. Okay, y2 is here. X exponent 2x. Okay, fx. Okay, fx, obtain the fx from the equation, from your right hand side of the ODE. So this part, okay, this is the fx. So a in this case is 1. So fx is x bracket x plus 1 times exponent 2x. So your fx is x plus 1 times exponent 2x. Okay, a is 1, w is here, exponent 4x. Then you make it, or let's see here. So exponent 2x times exponent 2x will be exponent 4x. This cancel. So this one you got dx. So you have integral of x, okay, and then x multiply x plus 1 will be have x squared plus x dx. So this is only a simple integration where you have, okay, so you integrate x squared will have x cubed over 3. Integrate x, you have x squared over 2. And then plus a. So this is the u. Okay, later on you integrate the v. V, which is the integral of positive v, this is positive, this is just replaced by y1. So what is the y1? Okay, y1 is exponent 2x. y1 you got exponent 2x. Okay, fx is x plus 1, exponent 2x. Okay, a is w, a is 1, w is exponent 4x. So exponent 2x times exponent 2x, exponent 4x, cancel with this exponent 4x. Then you just left integral of x plus 1 dx, where you get x squared over 2 plus x plus b. Then plug in the u and v into the formula of general solution, where the u just now that you obtained is negative x cubed over 3, negative x squared over 2 plus a. So you have, okay, u is negative x cubed over 3, negative x squared over 2 plus a. Okay, what's the what? Okay, y1 should be here. y1 is exponent 2x. Okay, the v is here. X squared over 2 plus x plus b. y2. Okay, y2. Here. y2 x exponent 2x. X exponent 2x. And then, okay, similarly, you will take the term with a and b first. So you have a exponent 2x plus bx exponent 2x. So bx exponent 2x. Okay, later on, okay, you expand the term. Okay, expand the term without a and b. Then you have here negative x cubed over 3 and negative x squared over 2 multiplied with exponent 2x. So you have here negative x cubed over 3 multiply exponent 2x minus x squared over 2 multiply exponent 2x. Then later on you have here, which is x squared times x, you have x cubed over 2. This is positive. X times x, and then you have exponent 2x. Right here. X squared over 2 times x. So x cubed over 2 exponent 2x. Okay, later on here. Plus x squared exponent 2x. So you simplify these two terms. Okay. So this one you simplify these two terms, makes a fraction, makes your denominator with the same k number. So this one I times 3. So numerator times 3. Okay, for the first term I times 2. This one times 2. So mean I got 6 here. Exponent 2x. So this is 2. Negative 2 plus 3. So mean 1.
1
1.
x cube.
So only x cube. X cube. And then here 1 x squared exponent 2x minus half. Minus half x squared exponent 2x. So you got half.
Positive half.
Yeah. So this is a general solution. If they provide the initial conditions, then you can get the value for A and B. So this is variation of parameter. Mean, okay, I repeat back. Mean, first step gets your YC is a solution of homogeneous equation, and then identify Y1, Y2, differentiates K to get your Y1 prime, Y2 prime in order to find the Wronskian in step number 2. Wronskian in step number 2. Number 3, find the U, which is negative integral of Y2 fx divided by A. Okay, A is a coefficient of second derivative. W is a Wronskian that you obtain in step 2. Okay, integrate respect to x. And then the V is actually integral of y1 fx over a w dx. Okay, after you obtain your u and v, the general solution is actually uy1 plus vy2. Okay, if your u and v, you don't put a and b. Okay, if you don't put a and b, doesn't matter. If you obtain this part is a yp. Let's say your u and v, you forgot to put your a and w. You forgot to put a and w. Then you obtain only this part is your yp. Then later on you add up with the yc that you obtain in step 1. Also okay, can. Mean the u, if you didn't put plus a plus b, then you can only obtain the yp part. Yp in the undetermined of coefficient. Then you just add up with the yc that you obtain in step 1 in order to identify your y1, y2. So, and any questions? Any question? If not, you can try. Yeah, who want to ask anything? If not, you can try to solve this one. You still have 1 hour. Any questions? If no, okay, I'm going to just stop the recording. Then you can take 1 hour to solve this one and continue your second tutorial for question 3.